Good morning, dear students. So today we will talk about types of chemical reactions. So far we have learned about chemical equations and how to balance them. Now let's talk about different kind of chemical reaction. There are different kind of chemical reactions, but only few are there in our syllabus, like combination reactions, decomposition reactions, displacement reactions, double displacement reaction, and oxidation and reduction reaction. And there are others reaction also, like photochemical reactions, electrolytic reactions, and there are others also. Now let's talk about combination reaction. Combination reactions is also known as chemical composition reaction, or you can say direct combination reaction. The word itself says combine. Combination means combine. And dear students, we know that to combine anything we require minimum two things. At least two elements or compounds are needed to combine. Let us see the definition of combination reaction. When two or more elements or compound, it can be elements also, it can be compounds also, when combines chemically to form only one new compound. Only one new compound is formed. For example, A plus B, it gives C as a product. So you can see there are two reactants and only one product. Such kind of reaction is known as combination reaction. Or it can be two or more also. A plus B plus C. It can be three or four reactants, but the product should be always be one product. And such kind of reaction is known as combination reaction. That's why I have underlined this one new compound. When two or more elements or compounds reacts chemically or combines chemically and form only one new compound, then the reaction is known as combination reaction. Now let us see examples of combination reaction. Quicklime, that is calcium oxide, when reacts with water, it forms slake lime, or we can say lime water, and the chemical name of this compound is calcium hydroxide. Also it evolves heat energy. Now you can see reactants are two, but the product is only one. This is delta H is for heat energy. Product is only one. So such reaction is known as combination reaction. And those reactions in which heat energy is released, such kind of reaction is known as exothermic reaction. The reaction in which heat energy is produced, or we can say those reactions which proceeds with the evolution of heat energy. Evolution of heat energy is known as exothermic reaction. That's a different topic. Exo means out. Thermic means heat. Heat out. So means heat is given out. Such kind of reaction is known as exothermic reaction. And those reactions in which heat is required, heat is going inside, so that's called endothermic reaction, which we are going to talk about later. Now let's focus on combination reaction. Various examples of combination reactions. Let me give another example of combination reaction. For example, magnesium ribbon, which burns in air, it forms magnesium oxide. Also it gives heat energy. So this is, you can see, one reactant magnesium, here one reactant is magnesium, other is oxygen from air. It forms magnesium oxide. Such kind of reaction is known as combination reaction. There are so many other ZNO. Okay, such kind of reaction are known as combination reaction. Okay, dear students. Now let's talk about a day-to-day life application of quicklime, that is calcium hydroxide. Quicklime is actually calcium oxide which reacts with water to form lime water. Let's talk about whitewashing of buildings. Before that, whitewashing of buildings, I want to tell you what is quicklime. Quicklime, in day-to-day life we call it tuna. Then calcium hydroxide is known as lime water, or we can call it as a slake lime. Slake lime, and the chemical name of this compound is calcium hydroxide, and that of calcium oxide is known as quicklime or lime. If you just say lime, it means calcium oxide, and then there is calcium carbonate. Calcium carbonate is also called limestone. Okay, now let's talk about whitewashing. In buildings, there is a whitewashing which occurs with the help of lime water. Lime water is used for whitewashing of the buildings. Lime water, or we can say slake lime. So this lime water is used for whitewashing the buildings. Now after 2-3 days, the atmospheric carbon dioxide reacts with this slake lime or lime water, and it forms milky white layer of calcium carbonate. Calcium carbonate, which is also called limestone, and the molecular formula is of marble is also CaCO3, and that of chalk, we use blackboard and chalk, that chalk is also calcium carbonate, which is milky in color, milk white. So this is actually a application, a use of slake lime. If you just use this water and we are using on walls of building, then what will happen? The carbon dioxide reacts from the atmosphere with this slake lime and forms a white layer color, and that white layer is of calcium carbonate. And also you might have learned in your previous classes, primary classes, carbon dioxide turns lime water milky. So this is the same application. Now let's talk about exothermic reactions example. Just now we have come across a word known as exothermic reaction. Exothermic reaction which proceeds with the evolution of heat energy. Those reactions which gives heat energy is known as exothermic reaction. Exo means bahar, that is out, thermic means heat. Heat is given out. Let's take examples of burning of coal. What is coal? Carbon. Carbon is solid. When burns in air, obviously oxygen is required for burning. Carbon dioxide gas is produced and heat energy is evolved. So this carbon is actually coal. Air have oxygen which is used for burning, and carbon dioxide gas is removed. and heat energy is given out. So the product is only one. Also, this is actually a combination reaction. Now let's talk about another example: burning of natural gas. What is natural gas? The main constituent of natural gas, the main chemical or the main gas present in natural gas is methane. Methane formula is CH4, it is gas, and when methane burns in air, the natural gas when burns in air, it forms carbon dioxide, water, and heat energy is removed. Gaseous state, liquid state, okay, carbon dioxide and water, and heat energy is evolved. So you can see burning of natural gas, methane when burns in air forms carbon dioxide, water, and heat energy is evolved. But this is not a combination reaction. You can see compound plus element, that is two reactants are reacted and two products are formed. This is not a combination reaction. Okay. Combination reaction are those in which only one product is formed. We are talking right now about exothermic reaction. Now let's talk about another example in day-to-day life. For example, respiration. Dear student, do you know what is respiration? Respiration is a process in which the breakdown of food occurs. The food which we eat goes inside our stomach, potatoes, chapati, and it breaks down into glucose. And the air which we breathe in, the oxygen which we take in, is used to break down the glucose, is used to break down the food. And during that process, energy is released. And that energy is used for walking, speaking. How we are surviving? We are surviving because of the process known as respiration. And in respiration, heat energy or the energy is released and is stored in terms of ATP. And that energy which we are using for our day-to-day life, like for walking, speaking, even sleeping. Sleeping requires energy. Each and every task requires energy. And all living beings are surviving because of energy, and energy we are obtaining, we are gained from respiration process. So what happens exactly? The food which we eat, let's define respiration. First, the breakdown of food, that is glucose, with the help of oxygen to give carbon dioxide, and water, and energy. The main purpose of respiration is energy. The food which we eat goes inside our stomach and then it goes in the blood, and it is digested into many things, glucose, amino acids. So the glucose which we is present in the blood, and the oxygen which we breathe in goes in the alveoli, that is the lungs, then it goes in the blood. So ultimately both glucose and oxygen is present in the blood plasma, and it is transported to the each and every cell to respirations and gives out carbon dioxide and water, and the energy which is released is stored in terms of ATP, and which we are using for our day-to-day life. Let's see this chemical reaction of respiration. C6H12O6, that is the glucose. Okay, it's actually food breakdown. It is actually solid, but when we are eating, it is digested and it is in the present of blood plasma. So it is in aqueous state. It is dissolved in the blood plasma. Then the oxygen which we breathe in is actually gaseous state, but it is carried by hemoglobin. So it is again the blood plasma. So it is aqueous. So oxygen which we breathe in is actually gaseous state, but when it is carried out by blood, it is dissolved in the blood and the hemoglobin, so it is aqueous. Now you can see this glucose C6H12O6 is breakdown. How many carbon glucose has? 6. It's breakdown into carbon dioxide and water. So C6H12O6 requires 6 oxygen molecules to form 6 carbon dioxide gas and 6 water molecules are released, and the carbon dioxide which is given out is also given out and it is transported by blood, so it is aqueous state and heat energy is released. So we are surviving because of the energy, and energy which we are getting is from food and oxygen. The food which we eat is stored and it is transported by blood. The oxygen which we inhale goes inside the lungs. It is also transported by blood to the cells. Now this glucose, which is a food, is 6 carbon, is breakdown into one single carbon, and so we can see it is a breakdown, and during this breakdown energy is released. So respiration is an exothermic reaction. Those reactions in which energy is released is known as exothermic reaction, and those reactions in which energy is required is known as endothermic reaction. Like for example, cooking, we are mixing vegetables, but the reaction starts only when we heat the mixture. So it is actually endothermic reaction in which energy is required. Like photosynthesis occurs with the help of sunlight. Without sunlight, it does not occur. So such kind of reaction is known as endothermic reaction. And those reactions in which there is no requirement of heat, only combine them, and when they are giving product, they will give you heat energy also. Such kind of reaction is known as exothermic reaction. So this was about combination reaction and exothermic reaction. Even in combination reaction, sometimes you have to supply heat energy, sometimes you have to supply pressure, catalyst, sunlight, electric current, or you may don't require them. You may require or you may not require in combination reaction. So this was about combination reaction and exothermic reaction. If you have any query, you can ask me on WhatsApp. That's it for today.